Welcome back to the Java OCP 21 series. I am Arup from ClusterMicro Technologies. So this slide, it covers one of the most precisely tested topics in the entire OCP exam. The exact order in which Java initializes a class and its objects, okay? So this is not about what the code does in general sense. This is about the exact sequence, step by step, line by line, in which Java executes each piece of initialization code. The exam will show you a class with field initializer, a static initializer block, an instance initializer block, and multiple constructors with chaining, and ask you what gets printed or what value a field holds at a specific point. So get the order wrong by even one step and your answer is wrong. Okay. So let me give you the complete picture before we read the code. When Java first loads a class, it runs static initialization exactly once. This includes static field declaration and static initializer blocks in the order they appear in the source file. Okay. So when you create an object with new, Java runs instance initialization every time. So this includes instance field declarations and instance initializer blocks in the order they appear. And then the constructor body runs. And if constructors chain to each other using these, the chain constructor runs completely before the calling constructor's body continues. Okay, so these are the rules. Now let us trace the code and see exactly what happens. So we have static int s. This declares a static field s because it has no explicit initializer. Java sets it to the default value for int, which is 0. So this happens when the class is loaded by the JVM. Okay. Then we have static s is equal to 10. This is a static initializer block. It is a block of code delimited by curly braces, preceded by the static keyword. So it belongs to the class, not to any object. Okay. So static initializers, they run exactly once when the class is loaded into the JVM. Okay, not when objects are created, not on every new call, once. The first time the class is needed. Okay, so after this static block runs, okay, s is equal to 10. Okay, so static initializers are useful for initializing static fields that require more than a simple assignment. For example, populating a static collection, reading a configuration file, or performing a calculation that needs multiple steps. Okay. So ordering rule is static field declarations and static initializer blocks run in the order they appear in the source file from top to bottom. If a static field is declared before a static block, the field initialization runs first. Okay. So if the static block appears first, it runs first. The order in the file is the order of execution. Then we have int x is equal to 5. So this is a field initializer. So int x is equal to 5. This is an instance field declaration with an initializer. Okay. So x belongs to each individual object. Every demo object created will have its own x field. Okay. So when does this run? Every time a new demo object is created as part of the instance initialization sequence before any constructor body executes. Okay, it runs. So at this point in the sequence, x is set to 5, but we are not done with the initialization yet. Okay. There are more steps before the constructor body runs. X is equal to x into 2. So what happens here is that this is an instant initializer block. So it is a block of code inside the class body but outside any method or constructor. Okay. Just curly braces with no keyword before them. So instance initializer blocks run every time a new object is created after field initializers but before any constructor body. Okay. So in this case, x is equal to x into 2. At this point, x is 5 set by the field initializer just before this. Okay. So x becomes 5 into 2 equal to 10. So after this blocks, x is 10. Okay. So why instance initializer blocks exist? Instance initializer blocks are very useful when you have multiple constructors and you want to share initialization logic across all of them without duplicating code. Okay, the block runs regardless of which constructor is called. It is essentially shared constructor setup code. Okay. So ordering rule is instance field declarations and instance initializer blocks run in the order they appear in the source file top to bottom. Okay. So if the field declaration int x equal to 5 appears before the instance block x is equal to x into 2, then x is 5 when the block runs. Okay. So if the order were reversed, x would still be at its default value of 0. when the block ran and the multiplication would give 0. Okay, so we have demo, then demo constructor, then system.out.println no arg x equal to plus x. Okay, so it is the no arg constructor. So it if you see that there is no argument in the constructor, right? So it's the no arg constructor. It has one statement only. It prints the current value of x. When this constructor body runs, all instance initialization has already completed. Okay. The field initializer ran and set x to 5, and the instance initializer block ran and set x to 10. Okay. Now the constructor body executes system.out.println no arg x is equal to x, so x is 10 at this point. So output will be no arg x is equal to 10. So this is the complete initialization sequence for a simple new demo constructor call. Okay, no args. So next we have demo intv this, then x is equal to v. Okay, so this is the one argument constructor. Okay, so as you see there is one argument in the constructor, so it's called the one argument constructor. It takes an intv and it does something important in its very first line. Okay, this. So this is a call to another constructor in the same class. Specifically, this with brackets with no argument calls the no arg constructor. Okay? Specifically, this with no arguments, it calls the no arg constructor. Okay, this is called constructor chaining. The rule for this is very strict and absolute. It must be the first statement in the constructor body, not the second, not anywhere else. Okay, this is the first statement. If you put it anywhere else, even on the second line, it will be a compiler error. Now let me trace what happens when you call new demo with 99 as argument. Okay, so if you see before any constructor body executes, the instant initialization sequence runs. Okay, so we have field initializer x is equal to 5, then instant initializer block x equal to x into 2 10, and then x is now 10. Okay, and then the chain constructor demo intv is entered. Java enters the body of demo intv. The first statement is this. Okay, a call to the no arg constructor. Java must complete the no arg constructor entirely before continuing with the rest of the demo intv. Okay, call. So we have system.out.println no arg x then plus x is equal to 10. So output is no arg 10, x is equal to 10. So no arg constructor completes. So in the third step, and in the fourth step we have, so it will be back to intv. Okay, so control returns to demo intv at the statement after this. The next statement is x is equal to v. Okay, so v is 99. The argument we passed, x is now set to 99. The constructor completes. The object is fully initialized. Okay, so final state of the object is x is equal to 99 and as is equal to 10. What was printed? No arg x, no arg, then x is equal to 10. It is one line only from the no arg constructor. Okay. So if we do the complete trace in exact sequential order again, so you can follow it up step by step whenever required. So class demo is loaded by JVM if not already loaded. Then static int as is initialized to default 0. Then static as is equal to 10, static block runs, as becomes 10. Okay. Then static initialization is done. This will never run again. Okay, then we have new demo 99, it's called, so instance initialization begins. Then field initializer int x is equal to 5, x becomes 5, and then instance initializer block x is equal to x into 2, x becomes 10. Okay, so the demo intv constructor body begins, then first statement this, then Java suspends demo intv and totally. Okay, and it will go and call demo no args constructor. The demo no arg constructor body it will run now, and it will print system.out.println then no arg x plus x, so x is 10 here, right? It will print no arg x is equal to 10. No arg constructor it will complete now. So after it completes, it will be back into demo intv. Execution will continue after this call. Okay, then we have x is equal to v, v is 99, so x becomes 99. So demo intv also completes. The object is fully constructed. X is equal to 99 and as is equal to 10. Okay, so there can be 4 traps here, okay, which you have to understand and remember. So trap 1 is instance initializers run before the constructor body, even with chaining. The field initializer and instance initializer block always run before any constructor body. Okay, so even when constructors chain to each other with this call, this this with bracket this call, the instance initialization has already completed before the first constructor body starts. Okay. And then we have trap 2. This must be the first statement, okay? So here if we see in demo int v x is equal to v, and if we call this as the second line, it will lead to a compiler error. This call must be the first call, okay? Then trap 3 is static initializers run only once. Static fields and static initializer blocks run exactly once when the class is loaded. If you create 5 demo objects, the static block does not run 5 times, okay? It ran once on the very first class load, okay? And S has been 10 ever since, okay? You have to remember that. And there will be a trap for the order of field and instance initializer in the file, it will matter, okay? So if you declare a field and an instance block in a specific order, they execute in that order. Swap them and you can get a completely different result, okay? The exam tests this by showing you a class with the initializer block before the field declaration and asking what value X has when the block runs, okay? So all these 4 traps you have to remember and understand totally. Hope we have been able to clarify all this. So let us meet in the next video.